안녕하세요. Hello and good afternoon. I'm Ernest Kung. I am the AI product manager for the Associated Press. Just a little bit about me. I am a broadcast journalist by training. I worked in local TV news in the United States for 15 years as a writer and producer. I left TV and went back to school to do a Master of Business Information Systems degree. And my research was on AI in journalism. So I want to talk a little bit about the Associated Press. So we are a not-for-profit, member-owned cooperative with operations around the world. We are one of the largest news organizations by footprint. We have journalists in more than 200 cities across nearly 100 countries. And so these are our values. AP has been delivering independent, nonpartisan news from around the world since 1846. Our mission is to advance the power of facts. So today, I'll be talking a bit about some uses of AI in journalism with a special focus on some generative AI examples. I'll start with an overview of the range of automation that's available to newsrooms. Then I'll go into AP's use of AI over the years. That will be followed by a discussion of the 5 projects that we built for local newsrooms, some of which use generative AI. And I'll leave time for your questions at the end of the hour. So we will begin with our first section on the range of automation. I'm going to begin with the recently published AP Stylebook Guidelines on Artificial Intelligence. Please read through this long definition. I was part of the team that contributed to updates on the stylebook, including these definitions. You can get the new section on artificial intelligence online at our AP Stylebook website, and it will be in print in our next edition. So as journalists, we need to be clear about the uses of AI and its limitations. This is important both for covering the impact of AI in society, but also for using AI to do our news work. Now, it is helpful to understand that there is a range of automation. I don't use the word automation as a substitute for AI because that's inaccurate. AI technology powers certain kinds of automation, but there are ways to automate things without AI. So at the top of your screen, at the simplest end of the range is what we call process automation. This can be a rule that triggers when you publish a story to a website. The headline and link is automatically pushed to social media as well. Up next is low-risk AI. This is AI that has been around for about a decade in news. This is the type of AI that powers templated stories and comment moderation. And of course, everything changed for journalism when ChatGPT was released last November, 1 year ago. I call this high-risk AI, where you can write fresh stories based on prompts or perhaps generate images. So let's talk about AP's use of AI. AP has had many years of experience working with artificial intelligence. Here's a look at some of the commercial tools in use or previously used by AP. Beyond automated writing, which was built in partnership with Automated Insights, we've partnered with a variety of other vendors. In addition, AI is used or has been used at AP for search, video transcription, event detection, and image recognition. In 2014, we made our own headlines by becoming an early adopter of automated writing, powered by the partnership of Automated Insights. This wasn't just a project to demonstrate the potential of AI, but it was something that solved a real problem. In our case, AP's business desk wrote about 300 stories each quarter during earnings season. But there are far more publicly traded companies that never got any coverage from AP. In all likelihood, that meant a company in your in a local market wasn't covered. So AP did have access to a data feed, like you see there in the background, that has earnings data from all companies. Using an AI-based template writing system, we generated brief articles that look like the example in the foreground. This process is highly predictable, repeatable, and scalable. AP expanded these AI-generated stories to cover all publicly traded companies in the US, and that was, at the time, some 3,000 companies. Note that at the bottom of the story, we include a disclosure of the automated process involved. AP includes a similar disclosure on all stories that are written using AI. And so, let me tell you about the impact within AP and outside of our automated writing technology. Our business reporters were able to shift their time to writing deeper stories rather than just trying to churn out the latest earnings report. No one lost their jobs. Again, no one lost their jobs at AP because of AI. Outside the AP, a Stanford University study found that our AI-generated earnings reports actually increased liquidity on the US markets. That's because companies that never used to have any news coverage were now being seen by potential investors. So, generative AI presents the opportunity to do a different type of writing, one that is driven by text prompts. AP's standards team has recently released this guidance on generative AI. And so I'll let you read through the notes here. If you can raise your hands, has your newsroom implemented guidelines for generative AI? None at all. And so this is a conversation starter for your newsroom. And just an overview, overall, AP does not use generative AI to create publishable content. We do have a lot of experimentation going on to help define what is possible with the technology. So there's a second part of our guidance. Here, the last item on this note, this long paragraph, should be especially concerning for all newsrooms. It is now perhaps easier than ever to generate altered words, photos, video, and audio. So, one of the newest implementations of AI at AP is with our AI-powered search. This is a feature currently publicly available as a beta at our member and customer website. You can actually access it on your own. Right now, as a member of the public, it is newsroom.ap.org, newsroom.ap.org. And we're using AI to power a new generation of search for images. And so this is one example. If you type in female politicians in blue dresses, this system returns these results. We use a vendor for this particular technology. It is a vendor named Merlin One. Let's head now to the 5 AI projects for local newsrooms. This is part of the Local News AI Initiative, which is just concluding its 2-year run funded by the John S. and James L. Knight Foundation in the United States. You can find all of our materials at ai.ap.org. We started with a US national research project in the fall of 2021. We published our groundbreaking report on AI in local news in March of 2022. And our local news AI program covers research, teaching, and building new AI tools. And so for the projects that we built, you will see a few common themes. First, generative AI was used in limited fashion to accomplish specific tasks. We recognize the technology is high-risk AI, and that's why we do our best to limit the risk. In all of our projects, we build in processes for oversight and approval by journalists. The goal is the same for all of our projects. It is to reduce workloads. We have open sourced, or will open source, the code for most of the projects. AP partnered with 3 universities to build these novel AI products. So here are the 5 projects that we released in September. These 5 were selected after a competitive process that had 43 projects pitched. A panel of independent judges picked these 5 projects. For El Vocero de Puerto Rico, it is a newspaper. We aim to speed up the publication of Spanish language weather alerts, which are especially critical during hurricane season. For Michigan Radio, our goal was to add new features to their Minutes application, which creates transcripts of city council meetings. When I use the word minutes, I'm using a term not for time, but minutes as in a transcript of what happened in a city council or a local government meeting. For KSAT TV in Texas, we built a system that can automatically summarize transcripts of recorded videos shot by the station's photographers. For the Brainerd Dispatch newspaper in Minnesota, we built a system that automatically writes police blotters. What a police blotter is in the US, police departments release every day or on a weekly basis a log, a list of everything they did during that period of time. So every time a police officer was sent to a location, that was logged. In the US, we have a common publication in newspapers typically, where we pick out the most interesting events from that raw log released by police departments, and then we write up a very brief story for a newspaper. Sometimes that brief story is 1 sentence long. It is a very time-consuming process, and we automated that for the Brainerd Dispatch newspaper. For WFMZ TV in Pennsylvania, we crafted a system that can automatically determine if an incoming email sent to a general email box contains newsworthy information or not. So I will go into further details now on the 5 projects. For El Vocero de Puerto Rico, they want to automate weather alerts, especially those for hurricanes. When an alert is received, the brief narratives from forecasters will be translated into Spanish. In the US, the agency responsible for issuing these forecasts is called the National Hurricane Center, and they publish everything in English. In our scenario for El Vocero, Puerto Rico, the dominant language on the island of the US territory is Spanish. And so there is a disconnect there where we have bridged it with a little bit of AI. So when the alert is received, those narratives from the National Hurricane Center are translated to Spanish, and a story template is filled in automatically. The draft story is delivered into their CMS or content management system. The goal of this project is to reduce the amount of time it takes to transmit a potentially life-saving alert to the public. We also determined in the course of this project that generative AI is not appropriate here. That's because the stakes are simply too high. As it is now, generative AI technologies cannot reliably write stories that are error-free. And so in this scenario where we're talking about life-saving alerts that need to be accurate on the first time, we do not risk using generative AI. And so at the bottom here is a basic flowchart of the process. The green boxes represent areas where we implement an AI technique. The blue boxes are process automation. So looking at this particular screen on the left side here, you see what the story draft looks like in the CMS. The CMS software, if I'm not sure if anybody uses this particular package here, it's called Blocks, B-L-O-X, Blocks. So we just simply connect into Blocks. Here are the technical details. Critically, the whole coding is done in Python, and you can see the various integrations. NWS is the National Weather Service in the US, and NHC stands for the National Hurricane Center. We tested several translation services. The English to Spanish pairing is one of the most popular translation pairs. It turns out many people in the US rely on Google Translate, and they get results that are less than accurate. Would be the best way to describe it. We settled on a German company called DeepL to do the translation, and I'm not sure how well they perform for Korean, from a Korean to English perhaps, but DeepL was extraordinarily well done in its results. Primary development for this project was at Northwestern University, and of course, we are open sourcing this project's code, so you may find inspiration for your own work right there at our GitHub repository. The Michigan Radio Project. They came to us with their existing system that was already developed for city council meetings. That system was already built with funding from the Google News Initiative. It operates across the state of Michigan by monitoring individual city councils across the state. For us, the goal of the project was to increase awareness for reporters of what happens in the city council meeting that they are unable to attend in person. So instead of just transcribing a video that comes in, we also wanted to generate alerts, and we also wanted to generate summarization. So if we can summarize a transcript of a city council, a local government meeting, we make it easier for the reporter to be able to skim through and find anything potentially interesting. Alerts are a separate issue where a reporter can program an alert. So if a particular topic comes up, they will receive an email alert with a link to that exact segment in the city council meeting. Fortunately, our development process ran into an unexpected challenge. The existing transcription system that was presented to us was highly inaccurate. They were using, as a Google-funded project, Google's speech-to-text system. And so Google's speech-to-text was highly inaccurate. We did a calculation which was called a word error rate. And so what we did was we provided 4 real city council transcripts. We paid humans to transcribe them. So we have a gold standard, a reference to go from. Then programmatically, we used a package that calculates word error rate to measure how different the transcript, the automated transcript, was from the human transcript. In the Google case, the results came back at, in some cases, 50% error rate. A 50% error rate is simply a coin toss in statistics. And so that is not acceptable, would be the bare minimum explanation here. Here, we ended up having to focus our resources on rebuilding the transcription system. So we did settle on OpenAI's Whisper model, which is their speech-to-text system that is available open source. You have to have the server processing to run it. However, you don't have to pay OpenAI to use it. There are multiple sizes of the model, which sizes, the larger the model that you use, the slower the processing. So we tested the transcripts on multiple ones. We settled on, from a technical standpoint, what's called a small.en, which is actually not the smallest, it's just the name of it. There's another one, a few other ones that are smaller. So we rebuilt that system, and now the word error rates for these transcripts are now in about the 12% range, was the final result. So we went from 50% word error rate down to about 12%. Why? You may be figuring out why these results may be different than your own experience. Why was the error rate so high? What we realized was the quality of the audio on the public government recording meeting is incredibly important. In the US context, city councils, local governments have to typically fund their own audiovisual equipment and their own webcasting equipment. There's no centralization at all. So in some cases, we had a city council where it's a large room just like this, where you had their government elected officials on one side and the public on the other. Imagine a large circle. In one case, they had one microphone in the middle, one microphone to capture the audio for the whole room. And so Google's AI had extraordinary trouble processing recording qualities like that, but OpenAI's did really, really well. So here is a look at the user interface. The transcript view is on the left here. I will point out a few interesting notes about this transcript. So in the block where it says 1 minute 30, you'll see that someone was recorded saying, "I will go home and shave, okay?" It's nonsensical. It seems like a transcript error, but it's not. When you listen to the transcript, it's very faint, but it's there. When you listen to the recording, it's there. This transcription system from OpenAI works extraordinarily well. In the US context, we have Native Americans, and so there are a lot of Native American names, tribe names. In the second block there, you will see them transcribed extraordinarily well. And so the system from OpenAI is very impressive in this situation. You can see the technical details on the right. Northwestern University was also our primary developer. In this case, this project is not open source, but you can request access to it at searchminutes.com. Here is a look at the keyword searches that are available in the system. This is a very simple search that everybody has. What is especially new is that we can do keyword-based alerts based on those searches. It ties it to a specific city government. And this is what an email alert looks like when you receive something that matches when the city council meeting includes a matching keyword. So our next project is with KSAT TV in San Antonio, Texas. They want to adopt a system that uses AI to transcribe incoming video and then summarize that video. The summary will then be uploaded to their CMS as a draft story. The goal is to allow digital producers the ability to publish a story faster, resulting in a higher overall volume of stories available on digital platforms. We did find that the generative AI summarization in this project is much more useful when there's a human in the loop. And you'll recall that phrase from Professor Beckett's presentation, a human in the loop. It is absolutely critical that before we go to summarization, that we make sure we have an accurate transcript. If the transcript contains inaccuracies, your summary is also going to contain inaccuracies. So we've added the interrupt into this process. we also found that there's a bit of a difference from the prior Michigan radio project. In our case, because the videos are professionally recorded by the TV station's own photographers, the audio quality is broadcast quality. It's perfect. So we didn't run into an issue of having enormous word error rates. In our scenario, the summarization uses OpenAI's GPT 3.5 Turbo model. GPT 3.5, they have multiple versions of GPT that have been around for a few years now. GPT 3.5 is the same one that underlies the initial release of ChatGPT. So ChatGPT is a public interface that you access on your browser. OpenAI offers a different level of access programmatically through code. So take a look at the left side of the screen. You will, for anybody who recognizes this, it is built on the Django platform. I don't know if anybody is familiar with that. The Django platform is an open source platform that makes it easier to create applications. It was in fact originally designed for news organizations. In this case, we are setting up a particular prompt to send to not ChatGPT, but OpenAI's GPT 3.5. You'll see the prompt text there in smaller text. I apologize, but in the smaller text, that was the final prompt that we used to allow the application to summarize incoming video. The primary development for this project was at Stanford University, and we've open sourced the code of this project. Here is the dashboard that we built. And so on the left side there, you see the title of the video. The category here is where we control the prompts. For the test purposes here, everything was listed as general, and that's what you saw on the prior screen, general prompt. The system is flexible enough to let users create and experiment with their own prompts. So after we released this project to the TV station, they started testing out different types of prompts for different scenarios. So in projects like this, it is important to experiment. You only learn from your experimentation. In the rest of the system here, you can see the transcript. You can see the summary status. ARC is the name of this content management system. It's ARC from the Washington Post. A big thing that I want you to notice is the summary button. Notice that when the transcript is done, it has the green check mark. But the summary, when it's done, it doesn't do a green check mark. Instead, it does the little cycle. Cycle as in recycle. The reason for that is we're taking advantage of the nature of generative AI. So generative AI, at a high level, means what you put in is not the same as what you get out every time. So this is different than our automated writing that AP has done for almost 10 years now, where the stock numbers that we go in, we know exactly what the content of the story will be at the end of the automation. This is different. With generative AI, we put in a transcript of a video, the same transcript of the video. Every time we run it through GPT 3.5, the summary is different. The summary is different. So we take advantage of that by offering this recycle button. By doing that, if on the other side, the journalist does not like the summary, they just hit the button and it generates a new one. Maybe they don't like it again. They generate a new one until they get something they like. And that is a particular feature that we have. So this is a look at the transcription system. Here we're using a commercial one called Trint. The reason we use Trint is because for this TV station, they already had a subscription to Trint, and we saw no reason to switch them out. It was unnecessary for the purposes of our project. On the right side, you can see the check boxes. This is when we talk about the human in the loop. We use Trint's built-in feature where a human checks each box manually to tell the system that they have completed validation or verification of the contents of the transcript. So in the CMS, this is the final output of what's received from the AI, from this AI program. The summary is, as you see there, that one paragraph. We also ask GPT 3.5 to generate story tags to help for searchability with the particular story. Our next project is with the Brainerd Dispatch newspaper in Minnesota. They wanted to automate the production of their police blotters, which I explained earlier. The AI extracts the incidents from the provided log from the police department. It populates a story template and delivers them as a draft story into the CMS. The goal of the project is to free up reporters' time by allowing them to tell comprehensive public safety stories rather than assembling just a very basic summary that is a police blotter. We found along the way that it will be worth exploring machine learning and or computer vision to power scrapers that do the instant extraction. This project uses standard scraping techniques, including an NLP library to extract addresses. NLP is natural language processing, and it's a form of AI. That is then hooked into the automated writing template technology to write the stories. In this scenario, generative AI is not used because of the need for consistent story outputs, as the nature of a police blotter report is extraordinarily basic in newspapers. Generative AI is unnecessary for this particular project. So here is a look at the user interface that we built. You can see approximately it's a PDF on the left side that reporters receive. They tell it which city, police department they're uploading for, and they hit the upload button. This project was built at the University of Missouri, and the code is also available on our AP's GitHub. This is probably the most critical part of this project that is representing a significant part of the time savings. So after a reporter uploads the PDF document, the raw police log, the system automatically reorders everything in the editorial priority of that newsroom. So every newsroom has their own editorial priority. We programmed in the priorities that matter to this particular news organization, and so it automatically sorts everything like that. The reporter, this is where the human in the loop is, the reporter goes through and they check each one that they care about. Sometimes the data quality, you can tell here, is highly inconsistent, and this is normal. It is not an error. It is actually the way it is. That police data comes in this fragmented format. So the reporter chooses the stories they wish to publish, and they quite simply hit the publish button on the bottom right. A few minutes later, going through a commercial natural language generation automated writing system, this comes back. This is a draft story in the CMS with a very basic description of what happened for a police blotter, and it replicates quite well what a human does. And later, the story will be cleaned up to be the format will be changed a little bit, but this is the raw text that comes back. And so our fifth and final project is with WFMZ TV in Allentown, Pennsylvania. The TV station wanted to use a machine-learned classification model to determine whether an email contains a newsworthy event. If it does, the email is uploaded into a planning calendar section of the CMS. The classification model was trained by the local broadcaster's own assignment editors. And if you aren't familiar with that job, an assignment editor, among their many jobs, is to determine whether an email contains a newsworthy event. The role of an assignment editor, it has different titles around the world. The person who sorts through emails and looks for interesting events. So what is an example of that? It could be, in our scenario here, an email advising that the president of South Korea will be meeting with a high-level diplomat from the United States. And so that particular email you would plug into your calendar for the actual coverage day. In our scenario, the goal of the project was to reduce the workloads for the assignment editors. And we found that it does take a lot of time to train a custom data model in the middle of a live news environment. What that really meant was that for a period of time, while the goal is to reduce the amount of work for the assignment editors, we actually ended up giving them extra work to do for several weeks because they had to mark up emails as whether with how they would have decided to do with that particular email, whether it was newsworthy or not. Additionally, there is a lot of statistical bias in the collected data. What that really meant for the data science students that worked on it was an extra challenge. In an academic sense, in a perfect world, when you're training a custom AI, a custom neural network model in this case, what happens is you would want equal amounts of emails. So you would want an equal amount of emails that are newsworthy and an equal amount of emails that are not newsworthy as your training set. However, as anybody in a newsroom knows, you get far more emails that are not newsworthy, have no editorial value than actually are newsworthy. And so that was a data science issue that had to be overcome. We also found, in this case, that generative AI is very useful here in doing extraction of dates and times from events in unstructured emails. So we're not asking it to generate brand new content out of thin air, like write me a story. We are asking it to find me the date and time in this provided text. Find me the date and time of the event. You may be thinking there are old-fashioned data scraping techniques that should be able to do that. Normally that would be the case, except in this, we're talking about emails that are completely unstructured data. And so because unstructured data, the date and time could appear anywhere. And so we found this tool being built with a custom trained model plus OpenAI. We've got two different forms of AI, and they work very, very well. So the project details there are on the left. In the end, we had 5,000 emails or so that were marked up. The data model, the neural network, returns classification for each email. Either they are considered newsworthy, unsure, or not newsworthy. In this scenario, the trained AI model is not part of our open source code because that is intellectual property for the TV station. It represents their actual human's judgment. So here's a look at a little bit of how we got the OpenAI, the generative AI, to work here. So this is a real email that was received, and we are it was already classified by the first AI as worthy. You can see at the top of the screen there, classification worthy. So the next bit is trying to find the date and time of the event. You'll notice many dates are mentioned in this email, along with many times. Turns out generative AI is very good. In this case, the correct date that we're looking for is August 23rd at 11 a.m. It does its job. So it returned the proper value so that in the planning calendar here of the CMS, we were able to plug it into August 23rd at 11 a.m. So in that calendar, the reporters, the journalists can be able to find that. We have an alternate process where if you are unsure, if the initial AI is unsure about what the classification is, we have an override button to be able to send it to the CMS. And so I will thank you for your time, and we'll move on.